Good morning. In today's class, we will solve some more problems based on moving charges. Take down first one. An alpha particle an alpha particle alpha particle alpha particle and a proton are moving in the plane of the paper in a region where there is a uniform magnetic field, where there is a uniform magnetic field directed normal to the plane of paper. Directed normal to the plane of paper. If the two particles have equal linear momenta, linear momenta, what will be the ratio? Of the radii of their trajectories in the field. Now let us read out this once again and we'll understand in a better way. An alpha particle and a proton are moving in the plane of the paper in a region where there is a uniform magnetic field directed normal to the plane of paper. If the two particles have equal linear momenta, what will be the ratio of the radii of their trajectories in the field? Now first let us write the formula for the radius of the trajectory. We know we have learnt it in when we learned the theory part. So radius of the trajectory, radius of the trajectory is given by R is equal to mv by qv, mv divided by qv. The radius of the trajectory is given by R is mv divided by qb, where m is the mass of the particle, v is the velocity, q is the charge and b is the uniform magnetic field intensity. Now it is given that the proton and alpha particle are moving with to the same field, and then they have, this is important, equal linear momenta. Therefore it is given that the alpha particle and the proton have equal linear momentum. So now if I take the mass of alpha particle as m alpha and its velocity is v alpha, so linear momentum is mass into velocity, which is equal to the linear momentum of the proton. mp into vp, that is proton. Now what will be the radius of that trajectory? So let the radius of the trajectory of proton is rp and that of alpha particle is alpha. So the radius of alpha particle r alpha divided by rp will be equal to m alpha into v alpha, m alpha into v alpha divided by qb whole divided by mp, I will write here q alpha, and b is same for both because they are entering the same magnetic field, into vp divided by q of p into b. So with this, let us cancel off. This is equal, m alpha v alpha is mp vp, so I can cancel this, and then b also will get cancelled. B also cancel. So I have cancelling out few terms. I can write r alpha divided by rp is equal to r alpha by rp is equal to r alpha by rp is equal to qp will come to the numerator, proton divided by charge of alpha particle, and we know that the charge of proton, alpha particle has 2 protons. Alpha particle has 2 protons and 2 neutrons. 2 protons and 2 neutrons. Alpha particle has 2 protons, therefore charge of alpha particle I can write it as 2 times E, because charge of proton is E, 2E. Therefore charge of proton is, if I take it as E, the alpha particle charge is 2E. So now E will get cancelled, and we will have R alpha by Rp is equal to half. R alpha by Rp is equal to half. So this is the ratio of radii of the trajectories by alpha particle and a proton particle when they are going into the same field with same linear momentum. R alpha by Rp is half. And this will complete this problem. Hope you understood this. Next you can take down another one. So let us do another one. Second problem. two identical charged particles moving with same speed enter a region of uniform magnetic field. Enter a region of uniform magnetic field. If one of these enters normal to the field, direction, and the other enters along a direction at along a direction at 30 degrees with the field. What would be the ratio of their angular frequencies? Two identical charged particles moving with same speed enter a region of uniform magnetic field. If one of these it should be these. If one of these THESC, this one, please correct it. If one of these enters normal to the field direction and the other enters along a direction at 30 degree with the field, what would be the ratio of their angular frequencies? So here also one of these enters, please correct it. One of these enters two identical charged particles moving with same speed enter a region of uniform magnetic field. If one of these enters normal to the field direction and the other enters along a direction at 30 degree with the field, what would be the ratio of their angular frequencies? So in one case the velocity and the field are normal. Velocity and field make an angle 30 degree. In the other case, the angle between field and velocity is 30 degree. So what would be the ratio of their angular frequencies? Now we should see whether angular frequency depends upon the angle between velocity and b. First, write down the equation for the angular frequency. The angular frequency is given by if I write the formula, angular frequency will be equal to, the frequency is qb by 2 pi m hertz, or angular frequency is qb divided by m. If you see the equation, it depends upon only the charge the field intensity and the mass. It doesn't depend upon the angle. Therefore, the ratio of frequencies will be 1 by 1. The ratio of angular frequencies is, because it does not depend upon the angle, the ratio of angular frequencies is 1 by 1, because angular frequency is independent of the magnitude and direction of velocity of charged particle in the magnetic field. I can write here, because the angular frequency is independent of the magnitude and direction of velocity of charged particle in the magnetic field. Velocity of charged particle in the magnetic field. Hope you understood this problem. So we completed this problem.